Welcome to topic number 13. In this lecture video, we're going to talk a little bit more about the functions. All right. So the first thing I want to talk about is something called the increasing, decreasing, and constant part of a function. So increasing function is on a given open interval where the graph of a function rises up from left to the right. Okay. So in other words, what we're looking for is from where to where on the x-axis the graph is going upward. So for example, if you look down here, right, this is a parabola, a U. So the part of the graph is going upward from left to right is right here. So that's the increasing part of function. Same thing with decreasing part of function, right? On a given open interval where the graph drops downward from left to the right. Okay. So what we are looking for is, from where to where on the x-axis the graph is increasing and is decreasing. Constant function, okay, constant part of a graph, or we call them constant function, is actually referring to a horizontal line where we're gonna denote it as f of x is equal to a number, whatever the number is. So here we will only use parentheses for the interval because we use the word open interval. Okay, so we will actually only use parentheses, okay, to indicating the part of the graph that is increasing or decreasing. Okay, so the trick is to find the point where the graph switches from increase to decrease or vice versa. So if you go left to right, this graph is going downward, this parabola is going downward to this point, and after that point, then it goes upward. Okay, so I'm looking for from where to where on the x-axis the graph is increasing or decreasing. So all I needed is the x value. So the trick is find this point, okay? When you do your homework, you got to find out the x value of this point where they make the switch. So the x value here is 3. So the increasing part of the function got to be from this x value 3, keep on going to the right, right? This arrow is pointing up, but also pointing to the right. This arrow pointing up, also pointing left. So my increasing part of the function is from 3, right? Open interval, always point is keep on, your x value keep on going to the right. Your decreasing part of the function, okay, from left to the right, your x value coming from negative infinity all the way to 3. There you go. Okay, let's try another one. So this one here is the same picture as I showed you before. Okay, so from left to the right, you can tell this is increasing part of the function, right? Going upward. So at this particular point, okay, let's make it a little bit bigger. From that particular point, after, is where the switch happens. It's because after this red point, after this x value, the function becomes horizontal, right? So that would become a constant part of a function right here. So what's the x value at that point? 1, 2, 3, -4. Okay, so this arrow pointing down and left, and this side keep on going just to the right. Okay, but the y value here is the same, right? The y value is actually just -1. So on the interval which the function is increasing from negative infinity, from where to where on the x-axis my graph is going upwards. It's coming from negative infinity all the way to -4, comma. All right, on the interval which the function stays constant, it stays constant from -4, keep on going to the right to positive infinity. There you go. All right, let's try another one. Okay, so this one, I can see from left to the right. This is decreasing, right? And then after this point, the graph goes upward. And then after this point, the graph going downward again. So I got one part that's increasing. So let's find out what the x value of these points. So the x value here, this red point is -1. This x value is +1. So the part of the graph is increasing is from -1 to +1 on the x-axis. All right, decreasing. So this arrow pointing up, but also pointing left. This arrow pointing down, but also your x value keep on going to the right. So the decreasing part of the function coming from negative infinity all the way to -1. So there's no union here. All we do here, this is not an interval notation. This is just describing, open interval. So I'm not going to use the letter U. I'm not use the union sign. I'm going to use comma to separate my two answers. So it's decreasing from -1, from negative infinity to -1 on the x-axis. And also it's decreasing from +1, keep on going to the right. Okay, so this is not an actual interval notation. So we just use parentheses for the open interval. All right, the next objective is talk about relative maximum, relative minimum. Relative maximum minimum is kind of like a mini max, mini minimum of the graph. Okay, so using the same picture for example, okay, you can find where you can find the relative maximum and minimum at that same exact point I just indicated. Okay, where the function go from decrease to increase and or increase to decrease. So if you trace this graph on left to the right, going downward, right? And then after this point, it's going upward. And then after that point, the function is going downward. So at this bottom point here, that's like your mini minimum, right? So we call them relative minimum. All right, so this one, right? The other point got to be the relative maximum. So here I'm only looking for the y value. When we're talking about relative maximum minimum, it's the y value that I'm interested in. So at relative minimum, the y value is -2. A relative maximum, the y value is +2. I don't need the x value. So all you need to do here is to say, write the y value of the relative minimum. So you can just say y equal to -2. Okay, that's all you have to write. The relative maximum occurs at the y value, y equal to +2. Okay, that's all it is. So if I go back up here, this picture, right? Okay, so if we talk about relative maximum, right? Relative maximum, so this will be at this y value, which is -1. As a matter of fact, this is kind of like an absolute maximum because the y value being -1 is actually consistent through, for as x keep on going to the right. So that's the idea, just the y value for relative maximum and minimum. All right, the next learning objective is called the even and odd function and its symmetry. So learning the even and odd function does help us graphing some of these functions I showed you back in topic 11 by hand. Okay, so if a function is even, okay, what that means is I will actually substitute a positive x value and then exactly the same x value but negative ones. If I input a positive x value and the same negative x value, right, like a 2 and a -2, then when the y value are exactly the same, okay, then my graph is actually even. Even function is symmetric with respect to the y-axis. So for right now, it's symmetric to the y-axis. Later on, it will actually be symmetric with respect of the axis of symmetry. That's what we will call it later on in a different topic. Symmetric with respect to axis of symmetry. So here, a parabola is actually considered as an even function. I input an x value and input a negative x value. If the two y values are exactly the same, then the function is even. The perfect example, -3, +3, right? The two y values are the same. What it means is symmetric with the y-axis or axis symmetry. What it really means is there is an axis of symmetry right here that cuts your parabola in two halves. So the distance from this -3, 5 to the axis of symmetry and from 3 to 5 to the axis of symmetry, the distance from those 2 points to the axis of symmetry is the same. Okay, that's what it means by symmetry with respect to the axis of symmetry. All right, so this parabola is a perfect example of an even function. A function f is odd function, where again I input a positive x value, then input the same number, just negative x value. If the two y value comes out to be opposite sign, right? This f this y value is negative, this y value is positive, then that means your function is an R function. R function is symmetric with respect to the origin. So for my example here, this is a cubic function, perfect example for a R function. I input -2 and an input +2. Then the 2y value has exactly the opposite sign. Okay, then my function is R function. Okay, so here I also wrote down if x is replaced with -x, then every term of the R function changes signs. That's how we can tell the function is odd without looking at the picture. All right, the equation of an even function does not change if x is replaced with -x, so that means everything is the same. So I'm gonna start you. So I'm gonna kind of start you off with a linear function. So in your own word, what would the phrase symmetric with respect to the y-axis change it to? Later on, you will change it to symmetric with respect to the axis of symmetry. Okay. All right. So let's try a linear function. I'm gonna replace -x for x. Okay. So I'm gonna substitute -x for every x that I see. All right, so simplify. Okay, so f of -x equal to -2/3 times -x is +2/3x. -1 still -1. So now let's compare the two answer. Does the two answer has opposite, look exactly the same? Both of these terms are negative. My new one is not. So it's not even. Even function, that means your two equation got to look exactly the same. R function is where every term has opposite sign. The 2/3 has opposite sign, but the -1 does not. So it's actually neither. Okay, neither even nor odd. All right, let's try a rational function here. Substitute -x for +x. So I'm gonna replace every x I see with a -x. All right, let's simplify. Okay, 2 still 2 on the top. Over -x whole thing squared is still good, will become +x squared, right? Negative times negative positive. X squared times 2 is still 2x squared, and that's still +3. So look at the answers. This is original function. This is the after we substitute with negative. These two functions look exactly the same. So that means this rational function is an even function. Okay, so what I mean is if I input a positive x value, like a 1, for example, and then input a -1, the 2y value will be exactly the same. So if you don't believe me, I can graph this real quick and just show you on the table. So parenthesis for the first term, 2 divided by denominator has an exponent, so I will actually put that in a separate parenthesis. 2x to the second power, close parenthesis for the 2x squared, close parenthesis for my first fraction term, then +3. So that will look like this. So if I go to the table, right, coming down a little bit. Okay, so see -1, y is 4. +1, right? The 2x value has opposite sign when the two and then the y value are exactly the same. So that means the function is even. All right, so in this lecture video, we talk quickly about your even odd functions, your increasing, decreasing part of function, and your relative maximum and minimum. So question number 1 and 2 come from the handout. All right, question number 3 here on the homework. Find the interval find the interval on which the function is increasing. So we got to find these points, right? This point right here, got to know the x value, just the x value here, just the x value, just the x value. Okay, then I will tell you which part is increasing and decreasing. Okay, so as you can see, this is decreasing, this is decreasing, and then this part is increasing, and that part is increasing. So only use x value, okay? The next one, same exact picture, except this time we are using the y value of the same exact 3 points, just the y value here to know the relative minimum and the relative maximum. So apparently these two points down here is your relative minimum, and this one up here is your relative maximum. Just tell me what the y value is. All right, so for this question number 5, do exactly the same thing as I just did with that rational function. Okay. All right, so that will conclude this lecture video. Thank you so much for watching.